So I'm going to try to answer the question, why do economists use elasticity instead of slope? When students first encounter elasticity, it can sometimes seem kind of cumbersome. So to remind ourselves, slope is just rise over run. It just says for any line that you're given, such as a demand curve, for every amount you rise, how much in either direction do you go, and for a demand curve, that's a negative relationship, so the slope is negative. That's a slope. It's a fairly simple concept. It's one that everybody learned in high school, so why don't we just go with that? Economists, we know, prefer elasticity, which is a percent change in the dependent variable, and when we're talking about elasticity of demand, that's quantity divided by the percent change in the independent variable, price. And first of all, why is quantity the dependent variable and price here the independent? It's because the firm is going to change the price. They might lower the price a little bit by 10%, say, and the behavioral response is that more people will come in and buy it. So elasticities measure behavioral responses. There's always an independent and dependent variable. One variable is responding to another, and the elasticity is how we measure that. But we could also measure it using slope, because after all, any independent and dependent variable relationship, we can always graph that. As a matter of fact, that's what economists like to do. We like to put these on graphs. So why do we stick with one that's less familiar to people coming out of high school and maybe a little bit more complicated and involves more calculations? Well, I think the biggest answer here is that elasticity works better with real-world data. I know we learn economics using nice linear supply and demand curves like this that come from your textbook because that makes it simple and easy to read. But when you think about a real demand curve, let's come over here and think about where does a real demand curve come from and what does it look like. So we know that real demand curves are really just lining up people in a particular order. And what order are we going to line people up in? The person who values the product the most gets first in line. So that person is right here. Let's draw a little picture of this person. And this person might value your product. Let's say the product is a fancy scented candle. They might value your product a lot. They might value it at $80, way up here. But that person's kind of crazy. The next best person only values that product at $50. So here we have $50. And then the next person over, the next person who would be willing to buy, they value it at $45. And then there's someone who values it at $35. Someone here. And then after that, there's someone who values it at $34, $33, and $32. I won't draw all these people here, but we know that there's a person on each piece of the axis, and the people are all lined up in the order that they value the product. So these people value it very similarly to one another. 35, 34, 33, 32. Actually, there's 3 people who value it at 32. So let's put all of them on the graph. And then there's another person who values it at 28, etc., etc., etc. So when you look at real data, a real demand curve is going to look kind of weird like that. Real demand curves are as messy as real people are, and they account for all the variation in real data. So if you're thinking about how do you set the price of this item, and you want to know if I lower the price by 10%, how many more people will buy from me? A slope isn't actually meaningful. The slope here is different than the slope here, is different than the slope here and here and here. So slope isn't super meaningful. Elasticity, on the other hand, is pretty meaningful. I want to say one more thing here. One thing is the elasticity and the slope, both of those depend on where you're starting from. If you're starting from here, lowering the price by 10%, taking $8 off the 80, is actually not going to have any behavioral response. So the elasticity, if you've already set the price at $80, is 0. Nobody's gonna come in and buy it if you lower the price by $10 or by $8 or 10%. Whereas if you're up here at 35 and you lower the price by $3, you're going to have a huge increase in demand. So up here, the elasticity is fairly inelastic, and down here, the elasticity is fairly elastic. And elasticity handles things better because if you lower the price by 10%, you're going to you might capture this slope and this slope. So how do you handle that? And elasticity is going to handle that much better than a slope. What would you do? Take the average of the two slopes? You certainly wouldn't pick one or the other because that wouldn't capture something real. Whereas if you lower it by 10%, lower the price from $35 to $32.50 or whatever that is, you can see exactly what percent change you have in the people here, and you're going to have, it looks like, almost a 50% change in the people buying your product. And that's a very simple measure that doesn't get all messed up when we have weird shaped data like most data is. A couple more things I want to say about this. One is, here's the classic inelastic demand curve, elastic demand curve. And so I just want to connect these with a couple of real-world examples. What does inelastic demand mean? It means that something like a pharmaceutical company can sit around and say, what if we increase the price by 200%? We're charging $50 per pill on this cancer pill. What if we actually not only increase it 100% to $100, but increase it 200% to $150? How many fewer people will buy the cancer drug? And since if your life's at stake, you're still going to buy it no matter what the price is, not that many fewer people will stop buying it. So that's an inelastic demand. It's a small behavioral response. We can change the price a whole lot, and the number of customers isn't going to change very much. The real life example with this one, it might be pencils or something like that. Let's say you're a company that creates pencils. There's lots of competitors. You're setting the price of pencils at 25 cents per pencil. Well, what if you decrease the price by 10%? Then suddenly everybody notices they have other options. They can just go buy pencils from other companies. If you decrease the price by 25%, lots of your customers are going to leave you. So the behavioral response is really big, and therefore this has an elastic demand. Finally, the last question I want to address here has to do with why the elasticity changes along a linear demand curve. And quite honestly, this doesn't really matter for real life, because in real life we don't have perfectly linear demand curves, but we do have demand curves with roughly that shape. And it also is a helpful exercise when you're learning about what elasticity means to go through this exercise to figure out, why does the elasticity change along this demand curve? And to think about that, I like to think about two different points. One is this point up here. Let's call this A, and another is this point down here. Let's call this point B on the demand curve. And at point A, if you're up here and you decrease the price by, let's say you decrease the price by about 10%. So this looks like about a 10% decrease. If this is the total price, this is about a tenth. So we have a 10% decrease in the price, and we know the price, when we're talking about elasticity, price goes in the denominator because it's the independent variable. 10% decrease in the price. How much increase do we have in demand? And we can actually map that. So if our price goes down here, the quantity is going to increase here. And when we look at this, this actually looks like it's increasing by 100%. If you start with this number of customers, that increase looks like roughly 100%. So we have 100% increase in the quantity sold. That's an increase when we decrease the price by 10%. So that's actually a pretty big elasticity. And that big elasticity happens at point A. We have the exact opposite, and let me get a different color here. We have the exact opposite when we look at point B. So point B, let's say, we'll do this the other direction. Let's say you're going to increase the price by 10%. Actually, let's say you're going to increase the price by 100%. So I'm going to increase the price from this to this. That's a 100% increase. Let's put that in our denominator. It's our independent variable. It's the percent change in the price. what happens to the quantity demanded as a percent. So we're going from this quantity sold to this quantity sold. So it actually only looks like there was about a 10% drop in the quantity demanded. So this elasticity is actually pretty small. And that is the reason why elasticity changes along a linear demand curve. So in this video, I hope I've answered the question, why do economists like to use elasticity as a percent change in the dependent divided by percent change in the independent instead of slope? I hope you're convinced here that it's more useful when thinking about real-world data.